the second half, we have our Hall effect sensor measuring the rotation of the magnets, which is feeding into the myDAQ, and we have an operational pulse counter. Unfortunately, because we can't get this to spin fast enough with just our hands, the frequency counter actually doesn't work because it's too slow of a frequency, but we can demonstrate that by turning this. If you look over to the oscilloscope, there's two signals there. The top one is the output of the Hall effect sensor. Unfortunately, the change right there is too small for the myDAQ to pick up, so what we did is we fed that signal to a comparator, and now the output is either 0 or 4.5 volts, which the myDAQ can pick up fine. As you can see over here on the breadboard, all I'm doing right here is just turning this back and forth, and one magnet triggers the Hall effect sensor on, and one triggers it off. And then, as I mentioned, the output of the comparator is fed back into here, and we have our edge counter. Just something real simple. You see, it just counted 17 edges. And then once we can get the car to actually drive that axle, we'll have a running frequency counter, which will basically implement this, and then every so many seconds it'll calculate the current RPMs. And that is the state of our project at this point.